In this video, we're going to talk about branching and loops. It might seem weird to wait such a long time in a programming language tutorial before we actually go through those constructs. But the reasons for that is because they're actually not that important because of Hyperlambda's declarative nature. So anyways, we're nonetheless going to have to cover these parts, and we're going to start out by looking at the if statement. Expand MISC, go to your evaluator. And we have touched upon these vaguely before. However, now we're going to touch more upon them. So let's first provide a dot source node, set its value to foo. Then let's provide a dot dest node and not provide a value for it. And then let's write if character return tab eq colon x colon at dot src character return dot colon foo character return shift tab to the indent yet again dot lambda character return tab set dash value colon x colon at dot dest dot colon yup. So let's execute this code, and as you can see, the destination node's value is transformed from null to yup. Why? Because as you can see here in the result pane, the if kicks in. How can we see that it kicks in? Because it's got a Boolean value of true. If we now change this to bar and we execute it again, you will see, well, it doesn't matter. Let's do bar for you will actually see that the bool evaluates, the if evaluates to Boolean false. If we change it back to foo again, watch carefully, line 3 here now, you will see that it evaluates to true. So this if statement here now evaluates to true, and when it does, it executes this lambda object. Now I want to emphasize if and while are exactly the same, except of course if executes its lambda object once, while executes its lambda object as long as the while loop's condition evaluates to true. So once you've taught yourself how if works, you also know how while works, assuming you understand basic looping in software development, of course. Now, what this basically translates to, if we are to write out this, and this is where Hyperlambda becomes a little bit weird, we are to write out this in a traditional programming language, then think about it like this: if, two parentheses, eq or equal dot source comma foo. That's basically what it becomes. You see, in a traditional programming language, you would write if, two parentheses like this, and then you would write dot src equal foo, right? Now, in Hyperlambda, the operator is on the outside. Why? Because Hyperlambda is a pure functional programming language. In fact, there doesn't exist operators in Hyperlambda. And the way to illustrate that is by simply invoking eq, colon x colon at dot src, character return dot colon foo. If you now mark this code, you remember from our previous video, we will only execute this code. And as you can see here, it evaluates to false. Why? Because we only evaluated this Hyperlambda. So this thing wasn't even a part of our tree. If we execute it again, it becomes part of our tree, and we will see it evaluates to true. So EQ is just the function like everything else. So is if is just the function like everything else. So is NEQ, which means not equal. So is MTE, which means more than or equal. So is LTE, which means less than or equal. So is LT meaning less than, and MT meaning more than. They're just functions. Basically, that's what they are. So when I'm writing conditions for my if here, I'm just supplying functions. This allows me to do stuff such as slots.create, if you remember this one from our previous video, return colon bool colon true, and then I can do signal colon foo. Now at the top here, I'm creating a slot called foo that returns true, right? And then further down here, I'm invoking that slot if the result of my first node in my if lambda object is true. After having been evaluated, it executes the lambda. So now we go to dot dest here, create our .test node. What do you think is going to be the result of this? And you probably guessed it. It resolves to Yup. If we overwrite our function, provide false, then of course it doesn't change at all. So if and else and equality comparison and all of those keywords in Hyperlambda aren't actually keywords, they're just functions like everything else. Let's do an else here, even though we have arguably looked at it previously. And as you can see now, it's no. Why? Because the else executed, as you can see, because it has a Boolean true value. Well, the if never executed or evaluated to true because it has a Boolean false value. This allows you to track the execution of how your Lambda object is actually branching as it is checking conditions using the if and else keyword. And of course, there is an else if keyword too, and it basically works the exact same way as if. It takes one condition, dot bool, can be a static condition like this, dot lambda, let's set the value here too, to else if. Now, because the first if evaluated to false, then it checked the else if, and the else if evaluated to true, so it set the destination to else if here, because that was what we chose to set it to inside of the Lambda object, to the else if. The else evaluated to false. Why? Because a previous else if or if evaluated to true. So the else was never evaluated whatsoever. It's basically just the same constructs as you have in any other programming language. They're just like different because everything is a function, because Hyperlambda is a pure functional programming language. Now, if we create, let's just for reference purposes, create a .no here. And then let's set its value to int 5. Then let's create while, catch return, tab, eq, actually empty, colon x, colon at, dot no, catch return, tab, dot, colon, int, colon 0, catch return, shift tab, dot lambda, math dot decrement colon x colon at dot no. Now we can remove this test thing here. So what does this basically mean? Well, it means while. Basically do over and over again. While dot no is more than integer 0. What is it supposed to do as long as the condition is true? The dot lambda object. The dot lambda object is decrementing no by 1. So of course what's going to happen is it's going to execute 5 times, and at the end of our execution our dot no has a value of integer 0 here at the bottom. Now this brings an interesting question. We saw it kind of previously in one of our previous videos. However, what happens if you created a never-ending loop with Hyperlambda? Well, actually try. Did you see that? Let me show it again and zoom in. You see, Hyperlambda is created to make it almost literally impossible to do something that can somehow, like, you know, mess up your server one way or another. If we allowed for infinite loops in Hyperlambda, and you had an endpoint where you had infinite loops, when you have, like, you know, 300 users having executed that, or 300 invocations towards that endpoint, you would have lost 300 threads on your operating system on your web server. Losing 300 threads is basically a big deal. It basically chokes the web server until the entirety of your web server, Nginx or whatever it is, dies and is recycled. That's a big deal. So the default amounts of while loops that Hyperlambda allows for is 5,000, as you can see, unless you change your configuration settings. So Hyperlambda doesn't even allow you to create never-ending loops. That was the point. Yet again, both while and if have these two things in common. They both take 2 arguments. The first argument is condition. Second argument is a .lambda object. It must be written as .lambda, and that is the code to execute for as long as the while loop, or if you're using if, evaluates to true, meaning its condition evaluates to true. Now let's do an exercise. And I will not show you what I have created here, but I have an HTTP GET endpoint, and it functions as follows. If I pass in an argument, set its value to Thomas, capital T, and I invoke it, it returns hi boss. If I change the name to John and I invoke it, it returns hi John. If I change the name to anything but Thomas or John, it returns hi stranger. Now I want you to implement this endpoint. And a piece of advice, you're going to need a .arguments collection. You're going to need to create a file in HyperID. It needs to end with .get.hl, and that file is going to have to contain the if, the EQ, the else if, and the else slot. Then it's going to have to contain the return slot. Did you figure it out? Now, I'm going to show you what I did to achieve this. So please pause the video if you still haven't done this exercise. Go to your Cloudlet and create a file whose name is tutorial05.get.hl inside of your tutorials folder. Now, I'm going to show you the file now, so please pause the video if you want to do the exercise. Such that you're not cheating. However, here is my file. First of all, it has a .arguments collection, it takes a name being of type string. Then it has an if. The if has its condition, an equality function invocation that checks the name in the arguments collection, and then it checks it towards the static value of Thomas. Then it executes this lambda object if the if invocation yields true. Else if, it checks to see if the argument is John, at which point it returns hi John. And then the final piece of the puzzle at line 18 here is an else statement returning hi stranger. And that is the code for this particular exercise. Now, let's look at for each. We're basically almost skipping while here, simply because it's the exact same syntax as if. So if you understand if, you understand the syntax of while. However, the for each loop is different. So let's have a look at the for each loop by opening up the evaluator. We have kind of like looked at it before, but we've never really studied it. Foo1, bar 1, foo2, bar 2, foo3, bar 3. Now, if I create a destination node here, and then I do for-each :x: at dot data / asterisk, and then I do add :x: at dot dest get dash value :x: at dot dp / hash, and this is where it's becoming interesting. If I now execute this code, I'm basically copying all of these nodes into my .dest node here. And it didn't work, so let's figure out why. Add into dest get value get nodes. Sorry about that. And now it's working. As you can see, we copied all of these nodes and we put them inside of here. Now, this syntax is kind of weird, especially this syntax. So let's analyze it. You see, the for each loop, it executes once for every single resulting node that results from its expression. Now, this expression, of course, returns 3 nodes. So that means that this for each invocation will execute 3 times. The first time it executes, the data pointer .dp, that's what dp means, it means data pointer, will be a reference important to foo1. The second time it iterates, it will be a reference to foo2. The third time it iterates, it will be a reference to foo3. Why is reference important, and what does that have to do with the pound sign here or the hash sign? Well, actually, that is what the this particular iterator actually means, because if we now click documentation here now, and we click the hamburger menu, and we find magic.node, and we search for that pound sign, you will somewhere down here see that this particular iterator retrieves the value of its previous result as a node by reference. What does that even mean? Well, actually, let's show what it means by doing lambda to hyper colon x colon dot dot slash asterisk log dot info colon x colon minus, and then execute it, and then open up our log. Now here you see we have 3 iterations. We have 3 nodes, so therefore we have 3 iterations. Then we're transforming the root objects, children nodes, to Hyperlambda string. Then we're logging that into our log. Okay, so let's look at it. You see this thing here, .dp? It was actually automatically injected by the for each loop. And actually you can't really see it here because we are iterating on the node itself as a root object. So when it's like transformed into Hyperlambda, the foo1 node for the first iteration actually is a root object. And when we're doing lambda to hyper, it actually doesn't convert the root node, only the root node's children. But the DP is of type node here. That is its type declaration. And it's being passed by a reference. This allows us to do stuff such as, for instance, we remove this code and we do set dash value colon x colon at dot dp slash hash dot blah 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 blah. You see now what by reference means. Why? Because I have a reference to the node I am currently iterating, allowing me to change it as I am iterating through. So that's basically what by reference means. So this is important to be able to transform and modify lambda objects as you are executing them. And that is basically how the for each loop works. Let's do another exercise. And this time I'm going to give you a data segment. .data foo1 bar 1 foo2 bar 2 foo3 bar 3. Now I want you to loop through all of these nodes. Bar 3, sorry. Now I want you to loop through all of these 3 nodes. And then I want you to change the value of all nodes whose name happens to be foo2. Now, piece of advice, the classic, there are multiple solutions to this actually, but the classic would imply creating a for each loop. Then inside of the for each loop, checking the name using get name of the currently iterated node, checking it towards a static value. And then if it is foo2, executing a lambda object that changes the value of the currently iterated node. So basically what I want you to do, I want you to start out with this, and I want you to end up with change like this. So you start out with this result, you iterate over each node, and then you end up with this. Did you do the exercise? If not, please pause the video now and do the exercise. Don't cheat, pause the video, go to your Cloudlet and do the exercise. So now here, because I'm going to show you 2 different ways of actually achieving this. I'm just going to keep this for reference purposes, wanted result. And then I'm going to show you the classic solution. The classic solution, of course, is to create a for each loop, colon x colon at dot data slash asterisk, and then apply an if eq colon x colon at dot dp slash hash catch return tab dot colon foo2 catch return shift tab dot lambda catch return tab set dash value colon x colon at dot dp slash hash and then dot colon changed. So this is probably the way most of you would have solved it, and it works. It is perfectly valid hyperlambda, as you can see, except it isn't. EQ bar 2, bar 2. As you can see here, this is perfectly valid hyperlambda, and it works, right? We're iterating over every single node here up in our .data segments. We're checking to see if the value of the currently iterated node is bar 2. If it is, we are setting its value to changed. So if you notice node 2 at line 6 here, then you notice node 2 at line 3 down here, it's actually changed. However, this is verbose code, right? So now we're going to provide a different solution. This is solution 1. Now we're going to provide a different solution. And this is solution 2, better solution. You see, when you have lambda expressions, they're actually encapsulating if. This is why I said in the beginning of the YouTube video that if isn't really that important. Because a lambda expression actually is an implicit if. You see, we can change all of this code. Here we have 1, 2, 3, 4, 5, 6, 7 lines of code. We can change it to simply set dash value colon x colon at dot data slash asterisk slash equal bar 2 dot colon changed. And this is the same code, basically. It's not the same code. It's way faster and way better and way less verbose, but it does the same thing. So you see, if you intelligently construct your lambda expressions, you can actually get away with few if statements. You don't need if statements that often. You do need them. I mean, it's not like as if Hyperlambda is a programming language where you never need to write an if statement, but you need them much more seldom than you do in a traditional programming language. That's basically because this is an if statement. Right, and it checks equality towards the thing we're looking for. However, this is probably the solution you came up with, and I want to emphasize this is a correct solution. It's correct, and it was what I actually wanted you to come up with. I just wanted to show you how you can sometimes get away with much less code by intelligently constructing your lambda expressions.